Okay, so just linking arithmetic sequences with sigma notation. So you can see what's happening here. I've got the sum from r equals 1 to 5 of a plus r minus 1d, which is the formula for the rth term, if you think about it. So ur is a plus r minus 1d. So if I start by substituting in r equals 1, 1 minus 1 is 0, and so I just get a. And then when r is equal to 2, I get a plus d. R equals 3. R equals 4. And r equals 5. So that was just to show you that that is the sum of an arithmetic sequence. The thing that I really want you to pull from here is the fact that this expression here in this bracket is a linear expression. So a linear expression gives an arithmetic series. So a series is when you add a sequence. So probably you could have put series in the title thinking about it, but that's the key point I'm trying to make. So I meant to do this as I went along. Right, so when r is 1 for this one, so this expression in the bracket is linear, so it's in the form mx plus c. The variable is r though, not x. And so when r is 1, I get 7. When r is 2, 2 plus 10 is 12. And then when r is 3, 17. And you can see that's arithmetic. And you'll always be adding on this coefficient of r. So it's plus 5. Plus 5. That one I can just add it up, hopefully. So that's 2936. But obviously, you know, if this number gets quite big, then you're not going to be wanting to add too many terms, and that's when you would go into the formulae to find the sum. So for this one here, we want to sum r equals 1 to 20, 4r plus 1. So I guess your thought process would be, okay, it's linear, so it's an arithmetic series. When r equals 1, 4 times r is 4 plus 1 is 5. When r is 2, I get 9. When r is 3, 13, etc. So a is equal to 5, and the common difference d is equal to 4, and we want to sum the first n terms, so n is equal to 20, and then you can use your formula for the sum, which is equal to a half n lots of 2a plus n minus 1d. So it's recognising it's an arithmetic series and then applying the formula. So a half for n is 10, 2a is 10, plus n minus 1, which is 19, times d, which is 4, and then you can just pop that into a calculator, which I haven't done. So 10 lots of 10 plus 19 times 4. Remember, your calculator follows big maths, you don't have to worry about that, and that gives you 860. So that's that one. You may find that you have a letter at the top as opposed to a number. So for instance, I might want to find that one there in terms of k. But it's the same idea. So we're summing from r equals 1 to k, we've got a linear expression, so it's arithmetic. The first term a is when r is equal to 1. And so 3 minus 2 is 1. and then the second term, when r is 2, so we get 3 minus 4, which is minus 1, and then the third term is minus 3, etc. So a is 1, and the common difference d is equal to minus 2. And so that's your coefficient of r again. And the number of terms this time is equal to k. And so this sum, using the formula for the sum again, is a half n, which is a half k, lots of 2a, which is 2, plus k minus 1, times this common difference of minus 2. So just tidying that up a little bit, I get a half k. It's just this bracket I want to tidy up. So 2, multiplying this out, minus 2k plus 2. And then that leaves me with a half k. 2 plus 2 is 4. 4 minus 2k. And it would make sense to times 3 by this half, or pull 2 out as a factor and do a half times 2 is 1. And then that will tidy that up a little bit more. So half times 4 is 2 minus k. But I would pull fractions out rather than put fractions into a bracket. It's only because this divides 3 by 2. And so that's that one factorised. So you get 2k minus k squared for that sum of the first k terms. And then going back to this one, if you want to sum the 6th term all the way up to the 20th, the way to do this is you can sum the first 20 and then you can take away summing the first 5. So that's the sum of the first, second, third, fourth, fifth, sixth, all the way up to the 20th term. And then if we take away the sum of the first 5 terms, that will leave me with the sum of the 6th to the 20th terms. So people who've done further maths are really used to that, but if you haven't, then just showing you one of those. That's what we did in part 3. And then this sum here, so in this case here, I've got the first term is equal to 5, common difference is 4, n is equal to 5, and so that sum is equal to half n, lots of 2a, plus n minus 1, which is 3, no, which is 4, sorry, times 4, so n minus 1d, so 2a plus n minus 1d. And then popping that into my calculator. That gives me 65. And so we end up with 795.